Good afternoon, all. On behalf of IoT Academy, I welcome you all for the fifth session of national level workshop on research paradigm and hands-on SPSS for beginners. Let me introduce the resource person of today's session, Dr. Sami Dubey. Dr. Sami Dubey is working with Acropolis Institute of Management Studies and Research, Indore, as an associate professor. He is a postgraduate in Commerce and Management from Devi Ahilya Vishwavidyalaya, Indore. He's having 17 years of academic and 4 years of corporate experience. He has worked for Worthman Politics Limited, Indore Institute of Management and Research, and IPS Academy, Indore. At present, he is having more than 30 national and international publications in research journals and conference proceedings. Dr. Dubey has also co-authored a book named Banking Law and Practice in India. Dr. Dubey is a member of Madhya Pradesh Economic Association and Research Foundation of India. He has also been invited as a speaker by UGC Human Resource Development Center for delivering sessions on ICT tools and research methodology. With this, I hand over the session to Dr. Samir. So, please. So, you are in mute, sir.
Thank you so much, ma'am, for a nice introduction of mine. And this is the last day where we are interacting on this 5 days national workshop on SPSS. And I believe that we have come across a long way. And the SPSS, there are certain tests, certain normality, validity. I believe that now you all people, all the participants are very much well versed with all these concepts. So today we are starting off with inferential statistics. So we shall discussing a little bit about inferential statistics, what exactly inferential statistics is. Statistics basically can be divided into two different parts. The first one is descriptive statistics that you have already discussed yesterday, and the second one is inferential statistics. So inferential statistics is something when descriptive statistics is something when you have already collected a data. That is called descriptive statistics. When you are only describing or summarizing the characteristics of a specific data set, that is called descriptive statistics. While in inferential statistics, what happens is where we used to draw certain kind of conclusions. We make certain kind of predictions based on our data. So when we have collected some sample from a data, we can use inferential statistics to understand what exactly are the characteristics of a larger population. Because what happens is when we collect a sample, it is assumed that the samples are identical with the population units. So inferential statistics have two main uses with us. The very first thing is it is used for making estimates about the populations. What exactly are the characteristics of the population on the basis of the sample that we are using. And the second use of inferential statistics is for testing of the hypothesis. So hypothesis actually helps us to draw conclusions about the population, whether there are relationship between two or more variables or not. What exactly is the relationship between two variables, whether it is a cause and effect relationship, whether there is any association between two or more variables or not. So all these things are part and parcel of the inferential statistics. Descriptive statistics actually allow us to describe the data set. Okay, and with the help of inferential statistics, what we do is we use to make the inferences. Now, what exactly are called inferential statistics? So in inferential statistics, we have different kind of hypothesis testing tools. Okay, so in inferential statistics. So in inferential statistics, what is happening is today we are going to discuss about different types of hypothesis tests. Hypothesis tests which are available with us are, as I believe we have discussed a little bit about the types of hypothesis. We generally used to make two different types of hypothesis. Hypothesis we discussed on our day one, where hypothesis is basically it is it is a statement, or you can say that hypothesis is something like which is the belief of the researcher. Okay, so now we have two different types of hypothesis, null hypothesis and an alternative hypothesis. So what happens is, what exactly is the null hypothesis? Null hypothesis is basically a statement where we test whether there is any association, and generally we used to state that there is no association, or there is no difference between variables, or two different parts of populations or subpopulations, like we can say. So this is a null hypothesis. In let us take certain examples, like there is no correlation between two different variables, and these variables can be frustration and aggression. These can be two different variables, and there is no correlation between these two variables. This is hypothesis for testing correlations. Then the average income for men and women are very much similar, or there is no significant difference between the average income of men and women of a specific community, or these kind of things. So this is once again a null hypothesis. Then a specific a cause and effect relationship. In a cause and effect relationship, the hypothesis could be like nationality. Nationality does not affect the music preference of people. So this is once again a null hypothesis, in which we have two different variables. It is nationality is one of the variables, and music preference is another variable. So there is once again association. Whether there is an association, there is no association between nationality and music preference. Then again, the average population income of certain of a specific year to a specific year related, or something means that there is a specific amount, that what exactly is the average population income. So these are the null hypothesis. Okay, then what we do is we used to test these hypotheses. There are different tests which we generally use for knowing whether the hypothesis we have, or the viewpoint that we have made, whether this hypothesis is correct or not, whether we are able to accept this hypothesis or not. So whenever there is a hypothesis, whenever the hypothesis is accepted, whenever the hypothesis is correct, whenever the data suggests that the hypothesis is correct, we used to call it as if the hypothesis is accepted. And when the hypothesis is incorrect, we used to call it as if the hypothesis is not accepted. It is not accepted, or we at some place they also used to call as if the hypothesis is rejected. So only thing is, we need to maintain the words that we are making. If you are writing that the hypothesis is accepted or rejected, then please use to make this only. It is only and whatever I am suggesting, it is only suggestions. It is only a request that we should have similar type of words. Either the hypothesis should be accepted and unable to accept, or the hypothesis is rejected and we are unable to reject the hypothesis. So these kind of words can be used. Another thing, while we are making the hypothesis, you will come across a value which is called a probability value. Or when we calculate the hypothesis, you will find a p-value. I believe that you would have discussed a little bit about the p-value yesterday. Whether p-value has been discussed yesterday or not, can anybody tell me?
No, sir.
No, sir.
Okay, p-value has not been discussed. Okay then. So p-value is basically, it is a probability value. So probability value says that if, for example, like if we compare about, or we take a sample about the wealth and happiness of say 100 people, and we find a correlation between these two variables, that is happiness and wealth, and let the correlation comes out to be 0.25 or somewhere near to 0. Okay, then what happens is we will get a p-value. So whenever we find a p-value, this probability value used to say that out of 100 or out of 1000 or whatever, at however number of times you are repeating the very same experiment, you will find a specific probability that a specific for a specific number of tests, what will happen is that you will get the very same number of results. Okay, so suppose if the sample correlation is found to be say it is a lower correlation, let us assume it to be 0.25, then that population is that whether there is no correlation between the two. So this will be known as this probability, that whether the correlation is 0 or not. This will be known with the help of p-value. So p-value is the probability. It is the probability of finding some sample outcome, or if the null hypothesis is true or not. Okay, so where if out of certain kind of graphs or out of certain kind of things, certain tests, you find that the p-value is somewhere near 0.05, then in that case, if it is less than 0.05, we generally reject the null hypothesis. If the value is less than 0.05, this you can, even if you want, you can write it down as well with you. So if the population or the sample, you can say, if the sample correlation or whether the correlation between sample and population is less than 0.05, then we will say that the hypothesis is being rejected. Okay, so this is p-value, and when we talk about the tests, you will once again get the p-value. Okay, then once another word that we generally use is confidence interval. Suppose our sample outcome suggests that some 95% of many samples should come up with a correlation between whatever the amount is. Let it be it was a lower correlation, so let it be between 0.05, 0.06 and 0.5. Then that range is known as a confidence interval. Okay, so although it is not precisely correct, but it's most easily thought of as the bandwidth that's likely to enclose the population correlation. So one thing to note is that the confidence interval is quite wide. It almost contains a zero correlation, exactly the null hypothesis we rejected earlier. Or another thing is that our sampling distribution and confidence intervals are slightly asymmetrical. So if they are asymmetrical for the other statistics as well, but not correlation, so there are chances that one kind of test is different. The p-value for one kind of test will be different, and the p-value for some other kind of test would be different. Now let us come to our parametric tests. So the tests, as I told you on the day one, that our tests are divided into two different parts: parametric test and non-parametric test. So now let us starting off with the first parametric test, that is one sample t-test. Please give me a minute so that I can open up that specific file. Now I believe that making an SPSS file, there is no problem. Here it is. I am taking two different files with this. I'll be sharing with you. These files also I'll be sharing with you. So there are two different files which I'll be showing you. Just a second. Let me open these files. And in one of the files, you will find that there is a single variable. Here it is. Just let me share it with you. Here it is. So everybody can see this now?
Yes, sir.
Okay. So this is our these are our observations. The observations are basically weight of the babies. There is a single variable that we have. Okay. So weight of the baby is the single variable, and this variable is numeric, then scale variable. Role of the variable can be left over. So this is, and normal baby weight, say it has only been just for the sake of keeping it over there. I have kept this baby weight over here. So normal baby weight is something. Let us go to the data view and let us observe these values. So weight of babies. We have a data of 100 babies at different times, born at different times, and this is their weight. Now let us check whether the baby's weights, this 2.5 kg is the normal weight. So whether the weight of babies born between a specific time duration or whatever it is, whether the average weight of babies is 2.5 or not. Okay, so let us, here we go. We'll go to the analyze tab. Then here you will find this compare means and a one sample t-test. Here is the one sample t-test. Now one sample t-test, this dialog box will open. What you have to do is you have to select weight of the baby and send it to the test variables. Then we'll go to the options. You will find that here is confidence interval written over here. Make sure that it is 95% only. By default, it comes to 95%, and we also have to remain it, let it remain there at 95%. Then there is nothing in like these missing values. We don't have to go to do any change in this, and just click continue. Then what happens is now we'll hit the OK button and we will find out the value of the test. Now one thing that we have not done is the test value. Okay, so just a second. Can you see the test? Can you see the outcome now?
No, sir.
No, you cannot see the outcome now. Okay, you are unable to see the outcome. Just a second. Let me share the whole screen. That will be sufficient, I believe that. So I am stopping to share this, and now let me share the whole screen. This will be helpful for you. Here it is. Now I believe that you can see the whole screen. Okay, now if you can see the whole screen, here the output is in front of you. Can you see the output now? Let me show you the input once again. Where was the input?
Yes,
Okay,
sir.
this is a different file. Let me show you where the input is. Oh, sorry. This is the input. Here is the input. So this is the input file, our data file. Okay, the weight of baby, and this is normal baby weight. It is 2.5. And what happens is we have calculated it. So here you will find this statistic. So this is the result. So the result is over here. One sample statistics. So weight of baby, N stands for number of observations, mean stands for the mean weight, standard deviation and standard error of the mean. Then one thing you will be observing here, it is written one sample test and the test value is 0. Can you see here the test value is 0?
Yes, sir.
Okay. Since we have not given any test value, this is the reason why it has taken the test value to be 0. Now what happens is the software has compared the average weight with 0. Okay, so weight of the baby is this, the t value of the weight is 58. The you will find this degree of freedom is 99. This is 100 minus 1. It is always your sample size minus 1. So degree of freedom is 99 minus 1. 100 minus 1 is 99. And this significance value, this is basically the p value which I told you earlier. This significance value is the p value. It is a two-tailed value, and this value is 0.000. It means that since this p value is less than 0.05, we shall say we shall state that the hypothesis there is no or the average weight of the child or average weight of the baby is equal to 2.5. But what happens over here is this significance value, this is saying that the hypothesis is rejected. Why? Because the value is less than 0.05. So whether it is true or not, it is basically wrong. Why so? Because the test value is 0. We have not put any test value in our test. So this is the This is the mistake from our side. Now let us correct the mistake. Once again, go to analyze, go to compare means. Here it is one sample t-test, and what happens? Here you have to put the value 2.5. There it is. So now we have put the value 2.5 or 2.50. It is of it won't make any kind of difference. And when you hit OK button, you will once again find the same statistic over here. You will find the result. So t-test here in log, you can say that you can see we have applied t-test 2 different times. This is the first time with a little mistake, and this is the second time with value input from our side. So now this is one sample statistic. Once again, this n or the number of observations is 100, means is 2.86. Earlier also this was 2.8630, and standard deviation is same, and the standard error mean is also very same. Now the one sample t-test. Now you see the difference. Weight of the baby is 7. The t value for weight of the baby is 7.380. The degree of freedom will remain as 99, and the significance value, a two-tailed value, will be 0.000 once again. However, for this time, definitely this significance value is correct. I'll be showing you another thing in just in a short period of time. Just a minute. Here is the mean value is 2.8630. We just need to remember this 2.8630. So the significance value once again is 0.000. That is, it is less than 0.050. So we shall say that there is significant difference in the weight of the baby. Okay, and we can see that the mean or the average of the weight is 2.8630. So we shall find, or we shall conclude that the weight of baby is on a higher side, since the average is 2.8630, and what we have stated in our hypothesis, that the weight is 2.50, but it is on a higher side. Our hypothesis is rejected. It means that the weight is not 2.50, but it is 2.8630. Okay. Now what happens if we change the test value? Here is the test value is 2.5. Now let us do one thing. Now let us make the actual average 2.8630 as the test value. What happens then? So let me show you. Once again, go to analyze, go to compare means, go to one sample t-test, and the value was, here is the value, 2.8630. Let me make it 2.8630. It is visible to everyone properly now? It is visible to everyone properly?
Yes, sir.
Okay. Now let me once again hit the OK button, and this is the third outcome. So the third outcome, what is happening here? The mean value is 2.8630. The difference you can find out, the t value is 0.000 and the significance value is 1.000. There is no mean difference. The mean difference is once again 0.00000. So now the significance or the p value is 1.000, which is higher than 0.05, and this will prompt us to accept our hypothesis that the average weight of the baby is 2.8630. Is it clear to everyone? One sample t-test.
Yes.
One sample t-test is clear to everyone? Alternatively, you can write down in the chat box if you want to write down something. If there is some problem in unmuting yourself and responding to the questions, then you can write down in the chat box as well. Okay. So this was one sample t-test, but this one sample t-test was once again with a single variable. Now let us do one thing. Now let us check, or let us test the very same thing once again with more than one samples. Okay, so here is more than one samples file. Here it is. I believe this is the variable view. I believe everybody can see this variable view. First, let me show you the data view. What exactly this data is. This data is basically about 4 different abilities. this was actually about the IQ of different students. We have assumed that there are say 100 or 200 students, and out of those 200 students, what happens is, if suppose the teachers is a little bit cautious about or anxious to know about the IQ of the students, and the IQ depends upon, and the overall IQ, it depends upon 4 different variables: the verbal ability, mathematical ability, classification ability, and logical ability. And the teacher wants to see, the teacher or the principal or whoever be the researcher, he or she wants to see whether the IQ level or whether these different abilities of a person, of a student, are equal or not, or whether what exactly is the situation with the ability of these students. And it is supposed that the average or the IQ level should be 100. 100 is supposed to be the normal IQ level. So now what happens is, let us test it. Now let us run the test. So once again, I go to analyze. Here is once again, let me show you the data view. So the first one is serial number. So serial number is, these are the randomly selected students. So this is the serial number of the students. Depending upon whatever you want to do, see, this can be like alignment can be done. So at present it is right aligned. Let me make it center aligned. It will do. And let us go back to the data view. Here it is, now it is in the center. These are the names of students, then gender. 0. Here let me show you once again. Here is the gender. Gender has not been mentioned over here. We can do one thing. We can put the value like 0 for female, and let us add it, and 1 for male. However, it is not actually required in this specific file, but still let us do it. So here it is. Now you can see in the data view, you will find that here it is, female and male. It has been bifurcated. Although this was not actually required over here. So here it is. Now let us go once again to the variable view. There is nothing special in this variable view now. Let us go back to the data view. Now you can find it out over here. Here it is. Now what happens is, we need to find out the average or the statistical average or the value for verbal ability, mathematical ability, classification ability, and logical reasoning. What exactly is the score? So now let us go to analyze, compare means, and one sample t-test. Now what happens is, we need to select, these are our test variables. These 4 are our test variables. So we will transfer them to the test variables block. Then once again, option is of no use. The test value, let the test value be 100. Okay. Now let us go to OK. Here it is. These are the test statistic over here. There are 2 different files, but the output is being saved in a single file only. So here is the output. Here you can see one sample statistic. So the number of persons, you can find that, you can see that number of persons or number of respondents in verbal ability and mathematical ability are 38. However, in classification ability and logical ability or logical reasoning ability, it is 34 only. However, it is not going to affect it a lot. But mean values are over here. Then standard deviation is over here, and standard error means once again. One sample t-test. Now what exactly one sample t-test used to say? What it depicts, what it reflects. So here you can see that for verbal ability, the significance value or the p-value is 0.727. And what shall be our null hypothesis for this? That this verbal ability is equal to 100. Here you can see the test variable 100. I believe everybody can see this. Test variable is 100.
Yes, sir.
Then the verbal ability is equal to the test value. The verbal ability of the students is 100. And you can find out that this significance value or the p-value is 0.727, which is definitely more than 0.05. Hence, we can say that our null hypothesis, that is the verbal ability of students is 100 can be accepted. Is it clear to everyone?
Yes, sir.
Now I feel it is clear to everyone. It is difficult actually for me to every time see that Google Meet window. Okay. So for verbal ability, our null hypothesis shall be accepted. For mathematical ability, our null hypothesis shall be accepted as the value is more than 0.05. For classification ability, although the value is 0.011, which is less than the value 0.050, and hence this hypothesis shall be rejected. It means that the value of the classification ability of students is not up to the mark. Now let us see what exactly is the average value for the classification ability. The value for classification ability is 93.91. Is 93.91, and 93.91 is and 100 are statistically more significant. So the difference is significant. Okay. So what we find is our hypothesis is being rejected over here. Either you will say not accepted, or you will say the hypothesis is rejected. So for classification ability, what happens is the classification ability of our students is not at all 100, is not equal to 100, or is not normal. Similarly, for logical ability, once again you can see that the value is 0.000, which is once again far less than 0.050. The logical ability, the mean for logical ability is 60.12. So the logical ability of students is far lower as compared to the standard value of 100. Is it clear to everyone now? So for one variable also we have checked. Here it is for marks, and for more variables, for more than one variable, this is for 4 variables also we have checked. Is it clear to everyone now? Can we move on to the next test? Should we move on to the next test now?
Yes, sir.
Okay. So now let us move on to the next test. This was one sample 2 test. Now let us move on to 2 sample 3 test. Okay. Just give me a minute so that I can. It is not being saved, and let me close these 2 files as well. Here it is. So this file has also been okay. Yes. Now let us go to. Now let me open that file with 2 sample test. So here is the 2 sample test. Okay, here is the file. Let us once again go to the variable view, or let us do one thing. Rather than going for this, let us first take a file with only 2 variables. Here it is. Then we will go for the file with more variables. So this 2 variable is basically for you all people to understand, and then with more variables so that we can understand how in practical situations we need to run the test. So here it is. We have 2 different groups. Just a second. Here it is. Let us go to the variable view. There are 2 different groups. So the group 1 and group 2. Here it is. Let me show you the data. Okay, the value of these labels. So group 1 is the diet group, and group 2 is the exercise group. This data has come from 2 different groups. The sample was divided into 2 different parts. One of the groups was being kept on a diet kept on a diet, and the second group was being put on exercise, like exercise kind of things. So what exactly was the cholesterol, the level of cholesterol between these 2 groups? Let us first check this. So this is the comparison. And the null hypothesis for this shall be there is no significant difference in the cholesterol levels of both the groups, the diet group as well as the exercise group. This shall be our null hypothesis. Let us go to the data. Here is the data you can find. Here is the groups. Here you can find the groups as well. If I put on the toggle button for this. So this is the diet group, this is the exercise group, and this is the value of cholesterol. Okay, this is the value of cholesterol deposited or has been tested in their blood. Okay, so now let us run the two sample test. We call it an independent samples t-test. Here it is called. It is called independent samples t-test. And these independent samples are from two different groups. And these, the grouping variable shall always be a nominal variable. Okay. So what we need to test? We need to test cholesterol levels. So here is the cholesterol level in the test variable part, and then the treatment group in the grouping variable part. Here it is. Now it will ask you that which are two different groups. So we need to define the groups. Our groups are group number 1 and group number 2. These are two different groups. Now let us continue. Options. You will once again find the very same options, 95% confidence interval, and you have to continue with this. Now we have already defined the groups. Now let us run the test by hitting OK. And here you can see the output. Here you can see the output. Okay. So in group statistics, you will find that the cholesterol concentration in mmol. Mmol is basically the unit in which the cholesterol concentration is being recorded. Then the diet group, number of persons was 20, and the exercise group, the number of persons was 20, equal persons from both the groups. The mean will be 6.18, 665 and 5.75. So there are two different variables. These are two different things we have found. There you can see the independent samples test. Okay. And you will find that this cholesterol concentration in mmol. So we have two different lines. You can see we have got result in two different parts, the upper part and the lower part. And this first thing, Levin's test of equality of variances, this is once again an important part. This plays an important role because you will find that these two variables only, this f and significance value, for Levin's test of equality of variances, this has single value. It is not into two. It has not been split into two different rows. Rest of the values are split into two different rows. So we have got two different outputs for our data. Now let us see. So this first let us assume, let us check what this Levin's test for equality of variances is. This test is being used for checking whether the variance for both the groups, for the diet group and the exercise group, whether the variance is equal or not. So what happens if we get the null hypothesis for Levin's test will be there is no significant difference in the variance of both the groups. There is no significant difference in the variance of both the groups. Or alternatively, we can say that the variance of both the groups is equal. Now here we have got a significant value of 0.091, which is more than 0.05. So what will happen? We shall accept the null hypothesis, that is, there is no significant difference between the variance of both the groups, or alternatively we can say that the variance of both the groups is equal. So what will happen? Now we have got an answer that the variances are equal. So we will use this upper row, equal variances assumed, and the lower row is equal variances not assumed. If this value would have been somewhere below 0.05, this significance value would have been below 0.05. In that case, definitely the lower row, we would have selected this lower row. Although you can see that the significance value in both the cases is 0.000. So our null hypothesis, whatever the null hypothesis is, that null hypothesis is actually rejected or not accepted. So the null hypothesis, the original null hypothesis was there is no significant difference in the cholesterol level of diet group and exercise group, and that hypothesis stands rejected. So there is a significant difference between the cholesterol levels of diet group and exercise group, and you can see with the help of mean, we can see that the cholesterol level of diet group is 6.18, a little bit higher as compared to the cholesterol level of exercise group 5.75. Thus, we can conclude that in case of exercise, if a person does certain kind of exercise, his or her cholesterol level shall be lower as compared to the person who are only doing dieting. Okay. Now these are independent results. It is compulsory, mandatory for us that these results are independent. So the person who is observing diet should not go for exercise, and the person who is doing exercise should not observe diet. This has to be clear over there. If the person who is doing dieting is also exercising, in that case the results will not be very much like reliable, one can say that. So one has to clearly make it sure that these variables, or sorry, these observations are independent observations. So whether this is clear to everyone now? Is this one clear to everyone? This is a
Yes,
two sample or independent samples t-test. How we, what are the assumptions, what exactly is the hypothesis, how to write down the hypothesis, and how to find out whether the hypothesis is accepted or rejected. So now let us go to the second file with multiple number of observations, with multiple number of, say, this variables. Okay, let us go to the variable view and find out what exactly the variables are over here. So ID is a nominal variable, then gender 0 is for male and 1 for female. Okay, these are here. This is once again nominal variable. Date of birth is over there, whether the parents are divorced or not. So this is basically for the parents of the children, whether they are divorced or not. So the level of their overall depression, like anxiety, depression, compulsive behavior, and antisocial activities. So these kind of things have been calculated. So 0 for not divorced and 1 for divorced. Okay. This is once again a nominal variable. All other 4 are on scale variable. So this is score on anxiety. Let me show you the complete, let me show you the complete name. Here it is. Score on anxiety test, score on depression test, then score on compulsive behavior test, and score on antisocial behavior test. Now let us run the, first let us see how the data looks, and then we shall run the test. Here it is. This is the ID. The ID has been provided. So we have 83 observations. The gender, male and female. 0 stands for male and 1 stands for female. Then date of birth, whether the parents are divorced or not. And then there are 4 different variables. Okay. So now what we are doing, we are going to test these 4 things. All these 4 variables we shall be testing. Let us go to analyze, then compare means, and then come to independent samples t-test. And these 4 variables shall go to the test variables column or the test variables box, and the gender, either gender or respondents parents divorced or not. So what exactly is your hypothesis? If the hypothesis is based on gender, then definitely we shall the grouping variable shall be gender. And if the hypothesis is based on respondents parents divorced or not, then in that case the grouping variable shall be respondents parents. So here it is, I am keeping it on respondents parents, whether they are divorced or not. So the group values, once again, group values are 0 and group values are 1. Here it is. Now continue with this, and once again hit the OK button, and you will get the output over here. Here is the output. Now you can see the output. These are basically the group statistics. You can see the group statistics. There are different number of persons in like divorced and not divorced, 49 and 34. And then here we come. This is what you have, what you can observe. So once again, the 11th test for equality of variances. Here you can see 0.005. It means that the results are, or the variances are there is no significant difference in the variances, and here the hypothesis is rejected, means there is significant difference in the variances or equal variances not assumed. So this value, this 0.052, this value needs to be used in place of this 0.035. If we ignore this value 0.005, if suppose we ignore this value 0.005 or 11th test for equality of variances, in that case we could have rejected this hypothesis because the value is 0.035. But what happens here? The value is 0.005. You can see the significance of this value. You can see the importance of this 11th test for equality of variances. The value is 0.005. So we are rejecting our null hypothesis. We are of the opinion here that the equal variances cannot be assumed. So here the value shall be 0.052, which is more than 0.050, and hence the null hypothesis shall be accepted or shall not be rejected. It means there is no significant difference whether the parents are divorced or not. So the divorce is not so the divorce of parents is not associated with the depression of a child. Is not, we can say that it is not the or you can say that it is not associated with the depression of the child. So here it is. In the very first hypothesis, you can say that the score of anxiety test. So the anxiety test is 0.159, which is higher side. So you can say that the hypothesis shall be accepted. It means that this anxiety test, the anxiety test or the anxiety of a candidate, it is affected by the divorce of whether the parents are divorced or not. So these are the results. These are the significant values, and this is how we have to either accept our hypothesis or reject our hypothesis. Is it clear to everyone now how to run and how to depict, how to write the hypothesis and how to find out the results or the conclusion on independent samples t-test or two sample t-test? Is it clear to everyone now? You want me to run the test again? Should we run the test again with another variable?
Yes, sir.
Okay. Let us check it once again. Now let us test. Now let us test the same on gender. Okay. Go back to analysis once again. Compare means, then independent samples t-test, and here you will find. Let us do one thing. This divorce, let us remove it and let us put gender over here as grouping variable. And 0 and 1 are once again the values. So let us continue and let us continue with the test, and you will find what happens. Whether gender, male and female. So whether the gender affects the different levels, anxiety level or depression level or like compulsive behavior test, whether male and female are different due to gender in these tests. Here it is the answer. So the anxiety test, there is no significant difference. Yes, there is no significant difference on the basis of gender. Then in the second test, you can see that the value, this 11th test value is 0.070. So we can say that this value is 0.070. So we can say that the variances, equal variances cannot be assumed, and the value is 0.020. So once again, the null hypothesis shall be rejected. Sorry, 0.290. So null hypothesis, sorry, it is 0.020. So null hypothesis shall be rejected, and there is significant difference in the depression of males and females. Then rest of the hypotheses are all accepted. So antisocial behavior, once again, the hypotheses are accepted. So there is no significant difference in the antisocial behavior of on the antisocial behavior of the respondent on the basis of their gender. So you cannot differentiate that whether the antisocial behavior of males and females are different. Okay, is this clear now? I believe this independent sample or two sample t-test is I believe is have been properly understood. Okay, should we move on to the next test? it is Anova, and then we shall conclude the session. Okay. So now let us move on to Anova. First, let me close these files. Here it is. This file can also be closed. No changes in the data set. And now let me open up the Anova test file. Here it is. Anova. Okay, here is the data file. Once again, we do have, this is the variable view. Let us come to the variable view and let us find out what exactly it says. So what exactly is the data with us? Here it is the data with us. Let us see. So ID, it is numeric. The width is 1 because we have only, here it is the data. You can see this is the ID. Okay, this is the ID. So this is only an identification number. So this is identification number. The values are none, missing are none. Then columns are 10 columns have been used. Then all these are right aligned. This is nominal value. The second one is once again gender. It is once again a nominal value, but it has two different values. Like 0 stands for male and 1 stands for female. Okay. So this is once again a nominal variable. Then birth date, date of birth. This is a scale variable. The second one is score on Beck's depression inventory. Some specific kind of inventory has been used. Inventory is basically named for structured tests which are already available in the market. In general, psychological tests are available in the market. You just have to purchase the test and run it or get the response from the people from these tests. So these are generally psychometric or psychological tests which are available in the market. So this is depression inventory. What exactly is the value of depression of persons that can be identified. So BDI is the depression inventory value, Beck's depression inventory value. Then BDI group. So diagnosed based on Beck's depression inventory and how it has been bifurcated: minimal depression, mild depression, moderate depression, and severe depression. So this is divided into 4 different parts. And then once again the medicine given to the person: none, then placebo, homeopathic, and pharmaceutical. So what kind of treatment has been given to the person? Here it is. Okay. Now let us do one thing. So these are once again nominal variable. So the groups are here different. It is BDI group and medicine group. So let us go for the test now. Here let us see the data view once again. Here is the data view. The BDI group, there are more than 1 BDI groups. There are more than 1 medicine groups. Once here you can see what exactly is the name of these groups also. So we can check. Now let us go to analyze. Then once again compare means, and let us go to one-way Anova. Here it is one-way Anova. Okay, paired sample t-test is remaining still. Just a second. Just a quick look at the Anova and then we will go for paired sample t-test once again. We have left that paired sample t-test. So here it is one-way Anova. The dependent variable is this inventory. Beck's inventory is dependent variable, and then either diagnosis or medicine administered. Or let us do one thing, medicine administered, let it be the factor. Okay, then we do have contrast, we do not need it. Then post hoc, one can say there are different post hocs available. Generally we use 2-case post hoc or either 2-case post hoc, or we use some Welch test as well. So at present we are not using it. Otherwise what we do is we use either 2-case post hoc. So post hoc can also be used if you want. Equal variance is assumed, then 2K can be used. Okay, so if equal variance is not assumed, in that case we can go for these tests available. Okay, so continue with this. Then post hoc we have already mentioned. We need descriptives. Then homogeneity of variance test. If you want, you can go for homogeneity of test, which will be required in case of certain different type of variables. So means plot is not actually required, and let us continue with this. And there you hit the OK button. And here is what you have got. So this is the descriptives that you have got. This is the descriptive analysis of all the things. This is test of homogeneity of variances, where the variances are are in homogeneity or not, or the variances are homogeneous or not. Then here is the value of Anova. Here is the value of Anova. So the value of Anova is basically this significance value 0.000. This actually depicts the value. This reflects the value of the test, and the hypothesis for this test shall be there is no significant difference. Okay, there is no significant difference in the BDI or this BDI level of the respondents of different type of medications. So here it is, and the result is in front of you. You can find the value is 0.000. So there is no significant difference. This hypothesis stands rejected, as the value is 0.000. The value is less than 0.050. So the hypothesis stands rejected. That is, there is significant difference between the patients of different kind of medications. Okay, so we have found that there is significant difference in the different kind of medications provided to the patients. Then here comes our, this is the homogeneity subsets. It is of not of very much use for us. Here is the post hoc test. Post hoc test is basically comparison between all these things. So when no medicine is administered, then what exactly is the whether there is significant difference, or whether there is significant difference between two of the groups. So no medications and placebo, it is 0.03. You can say that there is significant difference, since the value is 0.003, which is less than 0.05. Hence the hypothesis shall be rejected. So in case if you find out, you will find that placebo and homeopathic, there is no significant difference. Here you will find that certain results are repeating themselves. So the results are repeating themselves because these are every time all these four variables, like this non-medication, no medication shall first be compared with remaining three, then placebo shall be compared with remaining three, homeopathic shall be compared with remaining three, and pharmaceutical will again be compared with remaining three of them. So this is the reason why certain observations or certain results are repeated over here. So it is of no, do not at all worry about it. Let the value be there. Okay, so here it is. Yeah, so this placebo and homeopathic, they are significantly same. They are not statistically, the results from these two different kind of medications remains same. However, all other kind of medications, there are significant difference in the patients, or in the Beck's depression inventory status is different, significantly different in these three different kind of medications, except placebo and homeopathy. Is this clear to everyone? Is the one by Anova clear to everyone? If it is clear to everyone, let us take a quick look at the paired t-test. We have left paired t-test, unfortunately. If someone can please unmute and tell me. We are going to paired t-test now. Okay, please stay with me for say some 5-10 more minutes, so that we can go for the paired t-test. Okay, so here we are going for the paired t-test. Let me close off this file. Do not save, and let me proceed with this file. No, so here it is, paired t-test. I believe that the screen is properly visible.
Yes, sir.
Thank you so much. So here, let us come to variable view once again. You will find that the number of people over here, these are the respondents, that 20 respondents. Variable view. So the ID is a nominal ID is on a nominal scale. It is of no use for us. Then pre-test, marks before the test and marks after the test or after a specific kind of training. After a specific kind of training, before training and after training, the marks of students or the marks of the trainees are being put over here. Now let us see whether there is any significant difference due to training, whether the training has affected the performance of the respondents. Let us see it. So let us go to analyze. Then once again compare means since all these things. One more thing, another interesting thing is over there. One can do one thing while just going through the test. You can do one thing just out of curiosity or just out of looking whether the results are or how the results are coming. You can do one thing. In general, what happens is where there are two variables, people used to say that you should apply t-test, and where there are three variables or more than two variables or more than two groups, in that case we used to apply Anova. So do one thing, try to apply Anova in two variables as well. When you will apply the Anova, or when you will check, or when you will test, when you will practice these files, at that time try to apply Anova to the two variable to the two variable file or that two variable data as well. You will find that most of the results are very much similar, because Anova is only a special case of t-test actually. Okay, so even if you apply Anova to the two variables data, in that case also you will find the very same results. Now here it is paired sample t-test, you can see. So it is paired sample t-test. Now what happens is, the first pair, what you have to do, marks before have to go to variable 1 and marks after or post will go to variable 2. Okay, is it clear to everyone? I believe you can see this. Here it is. Let me keep it in the middle, in the center of the window. Once again, go to options. You will find 95% confidence interval over here. Just say continue over here. And what we need to do is, we just have to hit the OK button. Now let us see. Here is the output. Everybody can see the output properly, I believe. So this is paired sample statistics. We have mean values. We have both 20 respondents in both the cases. Since what happens when paired t-test is applicable? Paired t-test is applicable only when there is a single group of people. So these are the marks before a specific training and after the specific training of a single group. The group or the respondents should not change. Please make sure that the respondents should not change when you are applying paired t-test. If the respondents are changing, in that case you cannot apply t-test, this paired t-test. So this is the output. Paired t-statistic, paired sample correlation. So the sample correlation is also there. You can find the correlation is 0.717. This is a good correlation. Okay. So marks before and after have good correlation, moderate correlation, good, moderate to good correlation. And then paired sample t-test. The value, this is the mean, standard deviation, standard error, and here is the significance value. There is no significant difference, or there is no significant effect of the training. This is our hypothesis. The hypothesis will be there is no significant difference in the marks of pre-training and the marks of post-training tests for the candidates. And this hypothesis has been rejected. So we can say that there is significant difference. Alternatively, we can say that there is significant difference in the marks, or in the marks before the training and after the training, or you can say that the training has improved the results of candidates. So this is how we use paired t-test. Is it clear to everyone? Paired t-test is 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 also clear to everyone, I believe. Okay, now here I'm coming back. And this data, once again, I shall be sharing with you people. So we have completed our initial parametric test. We have completed this one. We have completed our t-test. We have completed Anova, and in t-test as well, we have completed one sample t-test, two sample t-test, and paired t-test. So all three types of t-tests have been completed, and one way Anova has also been completed. Now here it is. Okay, if somebody is having any kind of questions, you can ask.
The session is open for discussion now. You can unmute and interact with the resource person, or you can post the questions in the chat box also. I'll read it. He's there to help you. Please post your questions in the chat box.
Sir, actually, we are trying our level best to do the calculations. As it's the calculative part, we need some time to adjust and do trial and error. Once we are coming across the things, we will definitely get back to you with the questions.
Sure. So my email ID is with you, or you can interact with IoT Academy as well. So whenever whenever you go through these tests and you find any kind of problem, you can ask me a question through IoT Academy. They will be transferring all the questions to me, and when I'll answer, you will get all the answers.
Sure, sir.
Okay. So, ma'am, now should we wind up the session now?
I think there are no more questions. Shall we wind up, sir?
Sure, ma'am.
Yes. On behalf of IoT Academy, I thank Dr. Sami sir for the very interactive and innovative session, sir. And we thank you once again for the amazing presentations and calculations which you taught, which will be beneficial for the young researchers, sir. And thank you very much for this whole workshop, sir. It was an amazing workshop, and it was a really enlightening and enriching workshop, sir.
Thank you so much.
Thank you very much for your efforts, sir. I thank all the participants for joining the session today. Thank you all. Thank you very much, sir.
Thank you so
Thank
much.
you.
Thank you.
Kindly submit the feedback form using the link that has been posted in the chat box. Thank you all. Have a great day.